We all love great deals, isn't it? Whether it is food, apparel, or even a business looking for their raw materials. But we need someone to negotiate on our behalf. That's why we built Arbitrage 2.0. So let's jump in directly to the architecture. This is the architecture where buyer agents negotiate on your behalf with all the seller agents in the market. We basically create chat rooms for them to negotiate where all the negotiations from the seller's point of view are masked from each other. So let's move to the demo. This is the landing site. The complete architecture has already been initiated in Daytona, which you can see over here. The sandbox is ready. You can also see it on the Daytona website where we are using this project, where you can see the ID, which can be verified over here too. So let's get into the demo. So this is the landing page. Let's create a new session. A buyer can enter different types of details. Basically, it is about the uh, product name, quantity, and what's the minimum and maximum price that he is willing to pay. That's gonna act as the budget. The sellers have two different things. We have the priority, which basically acts as one of the aspects of the profile. The speaking style is also another aspect of the profile. The second thing that the seller has is the inventory status. It will have the item name, the cost price and selling price of the item, and the least price till which the agent is allowed to lower their price to. The stock quantity also helps in mapping the buyer and seller for the negotiation chat rooms. To simulate a real market, we have multiple sellers. We can add them. So for the demo, let's use sample data where we have a buyer who wants to buy a laptop and mouse, and then there are multiple sellers with different types of profiles and with different inventory statuses. Each of them has something different, may it be cost price, selling price, or the least price too. Let's get into initializing the episode of negotiation. So as you can see, based on the inventory status, we have mapped the buyer to the seller. So it knows that for mouse, it is not supposed to go in a chat room with all three sellers. So let's start the negotiation. So as you can see, the negotiations will be done in the sandbox with all the agents masked from each other. So as you can see over here, so a decision has been made. If you want to see the chats, we can see that they have negotiated over here. All the seller offers that floated around in the conversation can be seen over here, and the best one has been chosen. We all know that these were not the initial prices and were the final prices after negotiation. We can also do it for the second product and see it over here on Daytona. So again, the decision has been made and we can see the chat similarly. So here's where the feedback loop comes in. Going back to the architecture, we can see that there was based on the all the chat room conversations and final executed deal are sent to Claude for a deal analysis, and a final documentation based on the policy update is given. We can see it over here. So this is the analysis of the complete simulation of the for both the projects for both the products. Later, I will also show you the complete data logged in the Tigris data structure, as we have Galileo wrapping for observability. We will see all the we will see the negotiation chats logged as well as the final summary available on Galileo as well. Thank you. So as you can see on Tigris, we have the negotiation log stored. If we go over here in the bucket, we have sessions and we have two different folders. The two different folders are because we negotiated on two different products. In each of the folder, we have a JSON file, which we have already downloaded over here and can be seen like this. So yes, Tigris is working. So as we are using Galileo for observability of a complete agent environment, here you can see we have created arbitrage as a project. And in the logs, you can see all the different things. We also have all the negotiations logged over here. This is the analysis of the feedback cycle, which is given by the open router, which is using Claude. This feedback loop proposes all the different policy changes to be needed. Here, it is saying no adjustment needed because all prices are optimal for buyers as well as sellers.